Hello. So this is the second part of the 3.6 Rational Inequalities, and we actually did the application already with 3.6a, so this is just solving rational inequalities. Okay, so let's look at the definition of a rational inequality. A rational inequality is any inequality that can be put again into any of these forms right here, less than or greater than. Now, we're going to go ahead and solve and graph the solution set 2x over x plus 1 is greater than or equal to 1. And we're using the exact same steps that we did in the 3.6a. So our first step is to express the inequalities so that one side is 0 and the other side is a single quotient. So 2x over x plus 1 is greater than or equal to 1. So what we need to do is we need to move the negative 1 to the other side, or the 1 to the other side, I'm sorry, by subtracting 1. So 2x over x plus 1 equals negative 1 is greater than or equal to 0. And why did I put a equal sign here? It should look like this. Okay, now we want to combine. It's a single quotient. This is not a single quotient right now. So what we want to do is we want to multiply the negative 1 by x plus 1 over x plus 1. This doesn't change. It's just like 2 over 2 with fractions. So this doesn't change anything. It just, except that this will be, the negative 1 will be written as a quotient. So 2x over x plus 1 minus x plus 1 over x plus 1. So all we did was we multiplied both of these by 1, so it doesn't change. Now what we can do is we can rewrite it as a, or on the same line because we have common denominators here. So it's going to be 2x minus x plus 1 inside parentheses because we have the negative sign right there. Now we're going to distribute the negative. So we get 2x minus 1, x plus 1 is greater than or equal to 0 still. And we're going to combine like terms. So we get x minus 1 over x plus 1 is greater than or equal to 0. So now we have it in a single quotient. This is equivalent to this and to this. So we really didn't change anything except the way it looks, like the format. Now, our next step, step number 2, is going to be set the numerator and the denominator of f to equal to 0. So our numerator is x minus 1 equals 0. We get x equals 1. Our denominator, x plus 1 equals 0, is going to be x equals negative 1. Now, remember that this is the denominator. So x cannot equal negative 1. What did we just calculate here? We calculated the boundary points to figure out kind of where is it going. Now, we're going to locate next the boundary points on a number line and separate the line into intervals, just like we did with the previous, or just the regular inequality. So we're drawing a number line 0, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, and negative 4. Our boundary points, we have an x equals 1 and x equals negative 1. Now, we're going to go ahead and actually, there's a mistake here. This cannot equal, and of course it takes the whole thing off when I erase one little thing, or try to erase one little thing. It cannot equal x equals -1. It can equal x equals 1 because we do have the equal sign in the original right here, the line under. Okay, so we have intervals -1 to 1. So 1 is included, -1 is not. Actually, when we're writing the intervals, it's going to not be included because it's basically included in both of them. We're going to write it with the parentheses. So, and then we've got -infinity to -1, and then 1 to infinity. We can't include it in both right now because it's a boundary point. Next, we're going to choose one test value within each interval and evaluate f at that number. So our interval, we're going to start with that first interval, -infinity to -1. Our test value, the easiest number there is, we're going to pick -2. And we're going to plug it in the original. So this is the f of x equals x minus 1 over x plus 1. So f of -2 equals -2 minus 1, -2 plus 1. I probably should make the table here, which I was being lazy and didn't. -2 minus 1 is a -3 divided by -1. So f of -2, the negatives cancel each other out, is 3. So we have a positive here. The conclusion is that f of x within this interval is going to be a positive so greater than 0 for all x in -infinity to -1. Okay, our next interval is going to be -1 and 1. Well, there's an easy number of 0 right there in between those two numbers. F of 0 is going to be 0 minus 1, 0 plus 1. So it's a -1, which is a negative. F of x is less than 0 for all x in -1 and 1. Our third interval is 1 to infinity. Test value is going to be 2. So f of 2 is 2 minus 1 over 2 plus 1, 1/3. That is a positive. F of x is greater than 0 for all x in 1 and infinity. Okay, what were we looking for? We need to write the solution set, selecting the interval or intervals that satisfy the given inequality. So we need to go back and see what was the actual original question. Well, here it is. It is greater than 1, greater than 0. So we're going to look at all the ones that have greater than 0 here. So the original was this one right here. So the positives are -infinity to -1. -1 is not included because then we'll be dividing by a 0 right here, the denominator. Or 1 to infinity is a positive. 1 is included because we have the equal sign right here with the greater than sign. And that does not look like we have it. Now, another way to rewrite or write this would be inside braces. So as I said, x is such that x is less than -1 or x is greater than or equal to 1. If we graph this, on a number line, 0, 1, 2, 3, 4, -1, -2, -3, -4, right here. Um, -1 is not included and 1 is included. Now, you might see another way of writing instead of the dot and the circle. You might see a bracket and a parentheses as well. And those are just a different way of putting it on the number line, knowing that bracket is included and with the parentheses it is not included. And we're drawing the arrow towards the infinity and towards the negative infinity right here. Now, there is another way instead of, so this is basic, these are our answers. So that was the answer to this example. Now, there's another way of doing, instead of doing this table right here with the test value, what we can do, we still need the intervals, but I'm going to show you a different way of figuring that out. So what I'm going to do is I'm going to do the number line here. I'm going to do -1 and 1. Then I'm going to make a different kind of a table where I'm putting so we're using or taking first the numerator, x minus 1, and we're going to see what happens with -1 and 1. So if I sketch this one on a number line right here, if we think about x minus 1, actually that's the wrong place. So -1 is right here. So where would it go if we graphed y equals x minus 1? It would look like this, right? Because it's a positive x. So we know that before -1, this is going to be negative. Hold on a second. I have a total blank moment right now. No, this is wrong. Sorry. It was correct the original way that I did it. Um, if we so no, what I'm trying to do is x, hold on, let me take this graph totally out so that I'm not confusing with that. Sorry about that. I'm just having a totally blank moment right now. So x minus 1 is going to be negative between negative infinity and -1. We know that. X minus 1, if we plug in the 0, it's going to be 0 minus 1, so which is a -1. So it's going to be negative all the way to 1. And after 1, so the numbers after 1, it's going to be a positive, right? Now, we're going to take our denominator, x plus 1, and do the same thing. So x plus 1 is going to be positive, I'm sorry, negative to the left of -1. -2 minus 1, -2 plus 1 is going to be a -1, and so on. After -1, it's going to be positive with all these. 0 plus 1 is a plus 1, and 2 plus 1 is 3, so those are positive. Now what we're going to do is we're going to look at the signs here. And we're using the signs that, we have a negative and a negative, so that becomes a positive. Negative and a positive becomes a negative, just like we would in any quotient. Positive and positive stays as positive. So now this is negative infinity to negative 1. This is negative 1 to 1. And this is 1 to infinity. So our positive intervals would be negative infinity to negative 1 and 1 to infinity. So again, if we would plug in, for example, a number, let's do negative 2, then x minus 1 becomes a negative, x plus 1 becomes a negative as well, or is a negative as well. If we do 0, x minus 1 is going to be a negative, x plus 1 is going to be a positive. And then on this last interval, if we plug in 2, x minus 1 is going to be positive, and x plus 1 is going to be positive. And remember, this is a quotient, so it's x minus 1 over x plus 1. That's how we get the bottom line where it's positive and negative. Again, this is just a different way of doing it, just showing you an option instead of doing this table right here. We get the exact same answer. You feel free to use whichever method works for you. That's it for this lesson. Let me know if you have any questions. Bye.